Hey kids, Smath here. Want to go through progress check number 3 with you, put up a solution for it, walk you through a few things. Y'all did very well on this for the most part. Let's just go through a few stickly parts, make sure we go through each and every. So in first one, it said in box 1, draw the particle level diagram that represents solids, and everybody drew in nice, closely packed solid spheres and did a nice job. And then it said, hey, in box number 3, in box number 2, draw a particle that represents a vessel containing only gaseous particles. And so in that case, our gases are much more spread out, much more random, no order to them. They're just floating around. Pretty easy, pretty straightforward. Then it says, please respond on a separate sheet of paper, but let P and V represent, so if V over 2, and for the most part, everybody here said it would be 2P, or double the pressure. That was not a problem for us on this problem. Describe what happens. Now, C was a totally different story. This says, at a constant temperature, what happens to the speed? So in this case, speed is directly proportional to temp since temp is constant. Yes, you need to restate that. Comma, speed is constant. That's the phrase that pays. You need to have both of those phrases. The temperature is constant and the speed is constant. You could rearrange this and write it backwards and say the speed is constant because speed is directly related to temperature, but you had to have both of those. Okay, then we get to select a point value. Let's see here. The drawing circles are close. Okay. 2P. All right, so that was all we had for 1. 1 was very straightforward. You had a couple diagrams, you had temperatures proportional. Now in 2, we had NaCl and we had CaCl2. We had a couple of different questions. We had 0.20 NaCl is represented, 1, 2, 3, 4, 5, 6, 7, 8. So, and those are my Cl minus. My Cas are my whites. In the box represented above and the left, draw a particle diagram that represents the ions in the same volume of 0.10. So if it's half the volume but double the chlorine, then shouldn't the chlorines be the same? And so you would expect 1, 2, 3, 4 calciums, but then my chlorine, 1, 2, 3, 4, 5, 6, 7, 8. Now, there were 2 parts to this question, too. This said, you know, you could get anything for having twice as many chlorines as we would calciums. As long as we had 4 calciums, we had 8. That was the best answer. That was going to get you to both points. But if we just had twice as many, we'd be okay. But we're relating the 20 molar NaCl to the 10th molar calcium chloride. So it really should be the same 8 chlorines, just half as many calciums because of the charge there. Okay. In B, it says, briefly explain how the presence of the charged ions of ionic solids help to explain why NaCl is soluble in water. And there's a great discussion here about, NaCl dissociates due to the polar nature of water. And I read some great answers in this part about how the oxygen in the water was going to be attracted to the sodium and the chlorine was going to be attracted to the hydrogen. Those are all really good answers. And then in C, it says, what volume of 0.20 molar NaCl contains 10 grams of NaCl? So 10 grams NaCl, 58 grams per mole, and 0.20 moles per liter. Okay, and for the most part, that one went very well as well. So that was our progress check real quick on number 3. Progress check on 4 and 5 will be following. In the meantime, I'm Smath. I hope this video helped.